Hello, everyone. Welcome to Ortelius Summit, December 8, 2021. And in this talk, I'm going to talk about what is Ortelius and what are our plans regarding its upcoming architecture. Here's the agenda for today's session. We'll discuss about what Ortelius is, what is the need of it, why are we planning to change the architecture, and what are the considerations and the new and proposed architecture that we have. But before that, a little bit about myself. So my name is Ayesha. I'm from Pakistan. I am a software engineer by profession, and I've been in the industry for around 10 years. And at present, I'm working as an engineering manager in a local tech company. And I've been part of Ortelius community for around 1.5 years. And it's one of my first conferences. So I'm really glad and excited to be part of it. So yeah, that's all about me. And now let's move on to our presentation. So what Ortelius is? So Ortelius is basically it's basically designed for cataloging microservices. It tracks and version microservices, maintains the dependencies and the blast radius information, all of this by providing a logical view of the architecture. It's an incubating project that is under the governance of CD Foundation. And the mission is basically to simplify the adoption of microservices by providing a catalog that is maintained by the diverse and global and a constantly growing open source community that we have. So yeah, so why there is a need of a catalogs for microservices at the first place? I mean, to better understand, let's think of a scenario that let's say you're working on a product or a project that is designed using microservices and the consumers and customers are using it, right? And one day you got a call from a support that, okay, something is not working. What would you do in that case? Usually to cater the situation, we usually have observability in place, right? And that can help us debugging and identifying the service that is not working. So once we identify that, but the next step is usually we call the owner of that microservices and ask about that. And interestingly, what we might get to know that that maybe the owner of that microservice service or that developer said that nothing is changed in that service, right? Since its last successful deployment, everything is as it is. So this, I mean, what this implies, right? So this definitely means that something around that microservice is changed that is now causing it to break. So this means that apart from microservice, right, there is a need to track certain attributes that are associated with this microservice. So what are these things that that we need to track, right? So if we talk about microservice domain, so each microservice itself is a component, right? And that component it has its own deployment logic, right? I mean, a microservice can be deployed using Ansible or it can be deployed using Helm chart. And then it can be deployed to different environments, right? I mean, we can have test, prod, and stage, all these kind of environments with different environment variables attached to it. And then it can have an owner. It will be consuming some other microservices, and of course there would be other services that will be calling us or consuming this service. And then it will also have a blast radius, right? I mean, that means who this service is going to impact once it's changed. So all these are the attributes, the list here is basically the attributes that are associated with microservices, right? So yeah. So if we go back to the monolith case, right? So in case of monolith, what we have is that, or what we used to have is that we have a complete application, right, that is packaged together and it is linked and compiled, right? And in the end, what we get is an executable binary out of it, right? And it is a new version, and we can easily know and track the differences from the previous version, and we also know which version is deployed on what particular environment, right? But in case of microservice design, I mean, since each service is totally independent component, like I said earlier, so it's the concept of and a whole application version is something that's missing, right? We can track a single microservice, but a higher level, how things are impacted, is I would say that's missing. So what we have to do is we have to create and rely on a logical view to keep track of all those things, changes and differences. And this is what a catalog engine like Ortelius can provide. So yeah, so I mean, in summary, whenever a new microservice is created, so it needs to be registered to a catalog, and that catalog can actually track following attributes for it, like the pipeline. I mean, who owns that service, what deployment method it supports, key value pairs, secrets, inventory, version, logical application. So yeah, so this is all, this is what that we have to, like, we have to track. And that basically a catalog service do is to track all those attributes of a microservice. So yeah, I mean, now let's see, I mean, in this diagram we can see that how it basically changes the I mean, once we have a pipeline, right? I mean, that in which, like, when that an application comes in, and when it that eventually it goes to the its final environment where it gets deployed. So there's a whole pipeline to it, and let's see how how this deployment works when we have when we have Ortelius or a cataloging service in place. Then how the things will change, right? So we usually have a CI/CD process, right? And what happens is that in case of microservice, when how it starts basically, right? When someone pushes the code, right? I mean, and it passes certain tests and stuff like that. Then in the end, a Docker build or a container build is generated, and that is pushed to a container registry, right? So once we have that. So once that image is pushed to a registry, so what we got out of it is a digest, right? And I would say, or an immutable SHA, right? So what Ortelius does, it comes in and it captures that information, right? I mean, the get commit, the registry info, how the tagging is done, and then what it does is that it automatically creates component and application versions, and then it start building that relationship, that how this incoming service is being consumed, who is consuming it, what will be the logical app now looks like. And so and in the end, a new version of microservices will be created, and then of course a new version of complete app will be created. And then from in the as you can see in this, on the right side of the picture, so what Ortelius, after, I mean, capturing all this information, what it does, it can also trigger the deployment, that, I mean, deployment engine that can automatically do the deployment, or it can do that deployment using the existing CI/CD in process. And the end result is that it basically push out that microservice to the cluster, and of course, while keeping that, it's maintaining its inventory, that which environment is that microservice is being sent to, in case there are multiple environments, right? So these are some reports that we get out from once Ortelius does all this process. So these are some reports that can gets generated, right? So the first report that we have in the on the left side is the bomb report, right? This one actually from application standpoint, this diagram shows that what application is consuming, what is actually made up from, right? And then we have a blast radius. This basically tells that who is this service that is being changed or being pushed, right? And what are the other service that it has impacted? Like here we can see this card service has affecting 3 other services. Yeah. So down there we can see that there's a difference report that track and says that, okay, this card service got updated, the reason why it's being updated, and how it has affected the other services. All right. Okay. So now, I mean, this is all about the catalog service. I mean, this is all about what cataloging is and how Ortelius basically works. So now, I mean, let's shift our focus a bit to see that what is the architecture of Ortelius itself is, and how, I mean, what are the flaws that we are seeing and how we are planning to improve them. So yeah, so Ortelius, from architecture's point of view, it's basically a monolith app right now that's written in Java and C++ mainly. And since we have since we have Ortelius to keep track of our microservice, so now it's the right time to move Ortelius itself to microservice architecture. Yeah. So no, I mean, of course, that's not the only reason, but I mean, microservices moving to. I mean, there are a lot of good reasons that we have due to which we are planning to move Ortelius to microservice architecture, and some of them are written. You can see are mentioned here. Since I mean, it would be now easy to review the code, will have smaller services that can lead to less breaking changes, and the major thing is that since Ortelius is an open source community, it's a growing community, so we have a very diverse skill set of people that are coming in. So it would be good not to bound to a single programming language, and we can always have, I mean, we can do the development in parallel, and all those, I mean, these are the benefits that we are hoping to get out. I mean, these and many more benefits that we are hoping to get out once we have the Ortelius as itself is when it Ortelius itself will be converted to microservice architecture. So yeah, so this is, you can say, a pictorial representation of what the existing architecture of Ortelius looks like, and you can see that this picture in the right, it's simply telling that Ortelius, it's basically a Tomcat based web application, and the front end is in JavaScript, back end is in Java, and we have one single REST API class, and also there's a single DB handle that is connected to our Postgres DB. We have one DB and that is Postgres, and it's the connection is made via JDBC connection. And all of this, you can say, it's since it's a monolith app, so it's around 30,000 lines of code that we have at the moment. So yeah, and this is this is the proposed architecture that we are taking steps towards to make it look something like this. So in this approach, what we are doing is basically the approach we are taking is to divide the monolith to microservices, and then, I mean, how we are going to do is basically we will first the first and foremost thing to do is to identify the problem sets in our monolith code base, right? Once the problem sets are identified, and then once they're identified basically as a group of objects or functionality, once we have that, then the idea is to basically define the CRUD operations around it. And for example, I mean, an example could be that let's say we have our object identifies that deals with the credentials functionality. Right now, the functionality that deals with credentials is embedded in one single code base, and once we know what is this object and object does, and the CRUD operations around it are identified, we can make a microservice for it. However, I mean, there's one more thing, that this may not be the most granular division that we have. We can further split this microservice into two, and that's based on the type of CRUD, right? So we can have for every object, we may have two services. One is for read, and one is for write. So I mean, so read operations are basically the ones that are that does not update the database. So splitting the read and write, what we are trying to get out of is that since reads, there are more reads compared to write. So read microservice can be independently scaled, and since read operations are making no changes in databases, so that microservice can be tested against the actual production environment without fearing of breaking the prod database. Another important thing that we'll be supporting is that we'll be doing is the hybrid approach during that transition. This means that our monolith app will be running, and the new stuff that is being developed will be in microservice style, and will also be moving our monolith gradually to microservice. So will there will be, of course, there will be a time where we'll be in a hybrid state that where a monolith will be all will also be active, and then new microservice will also become part of this architecture. So do that, I mean, to support that kind of thing, we have service mesh, or more precisely Istio, that can help in that transition. And from yeah, so I mean, from implementation point of view, Istio is like it's a basic it's a simple YAML based structure, right, which can define rules, policies, and destination, and these destinations will then help us in routing the traffic to appropriate destinations based on certain rules. So during that transition phase, since our monolith is also, I mean, containerized, right? So it's itself is a microservice. I mean, it will be a big, huge microservice, but it will be a separate entity, and it will be the default destination for all the traffic that comes in. So uh, uh, yeah, so it will be the default destination for the traffic. I mean, that will be our monolith, and our news and all the new services, or any replace service. I mean, there is re-implementation of some part of monolith. We can define the new routes in our Istio configs, and then for each microservice. So any new call that comes in for a particular microservice will bypass the monolith and go directly to that microservice. So this is where Istio can play a huge role in supporting that hybrid phase. And not even that, Istio can but even after, I mean, once everything is migrated to microservice, we can of course make use of Istio during our testing and rollbacks and other stuff as well. That's the plan that we have. Yeah. So now, lastly, I mean, some points, I mean, some in my intro that I mentioned, that there are some considerations that some decisions that we made while moving to this while planning this architecture move. So some points around that I mean, first thing that we came across when we decide to move to microservice is basically the language choice. I mean, what would be the right language for our microservice, since each language has its own pros and cons. And let's say we don't have a time constraint, and instead of being trained on completely a new language, the idea would be to go with the one that I mean that the developers already well versed with, right? So however, I mean, tying back to the benefits of microservice, the thing that we should keep in mind is that in the end, the microservice should be simple, right? It should be simple enough to understand, make changes, review, and onboard new people. So what we did is we went with this 5-minute rules, right? Basically to figure out what a microservice does in 5 minutes. I mean, if someone is skilled in a particular language, then he or she should take only 5 minutes to understand what that microservice is doing. I mean, that's the, you can say, that's the rule that is put in place, because it's an open source community, right? And we have many new contributors coming in on monthly basis. So it would be so it should be simple enough that new people can be easily onboarded without going through any trouble. So yeah, so it's basically simplicity, that's the model that we are following. So for Ortelius, we have decided with the Python fast API. I mean, it was recommended that as I mean, why we went with the fast API is that it has a huge focus on REST API based backend microservices, and it was quick for us to get started. And based on And it's also based on an asynchronous server gateway interface. Hence, it's very fast in terms of performance, and the runtime environment is pretty small. It's at a very simple and straight Docker file. So the next thing is the database, which is of course one of the major component for any stateful applications, and it needs to be designed properly. There are again multiple directions to it. There is the choice of the database, SQL versus NoSQL, number of databases, database engine, basically poly versus single database, to name a few. So poly database is basically the one that's actually a separate database at times. A separate database engine too. Per microservice, we have a separate database. The advantages of this would be that we can put security measures around each database as per need in such a way that only one microservice can access this database. So apart from poly database discussion, SQL versus NoSQL choice is that we need to make based on the data that we are storing. So right now in Ortelius, as I mentioned earlier, that we have a SQL database, but that is not the best choice that we feel that right now. I mean, it was a traditional approach, which is kind of not very efficient due to high transaction load we'll have. So moving forward, the plan is actually use the graph database with a separate database and engine per microservice. The engines are usually lightweight, so it won't be an issue. However, I mean, the transition to new database is actually a major rewrite, and we need to have both databases running during our transition phase, which is of course, I mean, we would need an overlap that same entries will be inserted in both of them. So Ortelius is, I mean, is keeping the relational monolith database as part of transition. We are not going to change it at the same time as that of splitting the apps. I mean, reason being is too big of a lift at this time. So we'll first, you can say, divide our monolith to microservice, and then we'll move on to rewriting the database part. Since these two, if done in parallel, it would be too big of a change that we feel can that would happen. So yeah. Yeah, and one more thing is, I mean, the application, and then the database, and the third thing that is basically, I mean, once we in designing the database, apart from storage, scalability, availability, etc., these major, I mean, there are other things that should be kept in mind. Is basically the design of that transaction layer, which is basically how to retrieve and store data into database, like how to interact with the database. This is kind of closely linked with the functionality of microservice. So I mean, ideally the each table in a database will have its CRUD operation, and that will be of course written in the corresponding microservices. So some things that to keep in mind, I mean, we'll of course keep in mind would be around the transaction layer. I mean, once we design that, once we'll come to that point when we design that transaction layer, so would be to minimize the breaking changes. I mean, it should be backward compatible. So this can be done by making use of defaults at the input side for the values which are not supported in the new version, as well as adding data structure at the output side, retain the old columns in the database, and I mean that will be removed eventually when no one is using them. So I mean, so the main thing is not to break the database while moving to the other version. And another thing would be, I mean, Ortelius right now has huge data store in it. So, I mean, one small thing but important thing would be that is basically to avoid the select static query, because it can cause a lot of load on the DB. I mean, it may not hurt in the start, but this is something that can hurt in the longer run once the DB size grows. And third thing is that I mean, microservices, since it's microservices and all of them are interacting, so microservice might have to call another microservice. So we'll have to make sure to avoid any circular references. So yeah, so in Ortelius, Yeah, so in Ortelius, I mean, right now, what we have is the DB class, the database class. We have a database class. I mean, that's the only class interacting with the database, as I've shown in my existing architecture diagram. Here you can see we have a single DB that is 20k something lines of code, and now like I explained earlier, the plan is to limit our database interactions to one or two tables as per microservice, so that it can simplify and and prevent the above mentioned issues that I've explained. So yes, that's all I have to say. And thank you very much for joining the session. And if you have any questions or anything that you would like to discuss, feel free to reach out to me. I can be reachable on LinkedIn. This is my handle, and also I'm part of our TGS open source community and Discord channel, so you can reach out to me there as well. Yeah. Thank you so much.